two linear equations in two variables, we know that we can encounter three different situations. One, unique or single solution if you want. The other one, no solutions. And the last one, infinitely many. We had a lot of examples of this. I would like to show an example of this, and I would like to show an example of this. Okay, so here's the system. Okay, so I'm looking at the system. I'm going to multiply the first equation, let's say, or the second one by -1 because I want to eliminate x. Or I meant to write y here, of course, 4y. So let's say I want to eliminate x. So I have -2x and then plus 4y equals -3. I copy 2x minus 4y equals -4. I add the two equations. 0 equals -7. I know for sure that lines are parallel and no solutions. I got a statement that is false. I could never accept that 0 is -7. So therefore, and obviously I created a very simple situation. It's clear from here that 2x minus 4y cannot be 3 and at the same time -4. It's not possible. So the lines are identical in the sense that they have the same slope. I shouldn't say identical. They have the same slope, right? They will be parallel. They will have different y-intercept, but they will be parallel. They will have the same slope. So therefore, it's this situation, no solutions, inconsistent system. Okay. Now let's look at this situation. Very good question. Thank you for asking that. So here is, oh, I'm sorry. Any questions on this? Is this okay, everyone?
Yeah.
Okay, so now let's take a look at this situation. Okay, here's the system. I see that it's a 2 by 2. I know I can expect 1, 2, or 3. Nothing else can happen. So I'm looking and I'll say, oh, I want to eliminate y. I will multiply the first equation by 2. I will copy the second equation. I will add. But this time I fully accept this. This is indeed true. But I didn't find any x, which means lines are identical. Which means infinitely many solutions. Very good question. Now, I'm not going to insist on this, but here is how we write the solution in this case. We look, let's say, at this equation because I can solve it easily for y. So I will move y to this side and 10 to the other side. So 4x minus 10 equals y. So x can be anything, but y will depend on it. This is the way we like to write infinitely many solutions. Which means when x is 0, y is -10. When x is 1, y is -6. And I can go on forever. Again, I'm not going to insist on that, but this is the way we write it. I'm happy with writing infinitely many solutions. So what we do is we solve for any of the variables. It doesn't matter really, but it's easier to solve for y. So y is depending on x, So x is x. For any x, I will determine a corresponding y. Thank you, Kimmy. Very good questions. Anything else? This was very, very useful. Thank you. That's what I rely on my students to come up with other questions that I didn't get the chance to address in class. Excellent. Good. Next question, please. Thank you. I posted an old test 3, so after we finish, we'll go to that or to any questions you may have. Anything else you need help with? Anything? Anyone? Please. Kimmy, is this okay? Is this sufficient for that?
Yeah, that definitely cleared up like everything.
Thank you. Thank you. That's all I needed. Okay, ready then to continue and finish up 8.1? So let's, before my system brings up my multimedia library, so let's summarize. We talked about the sigma notation. We talked about factorial notation. And we talked about how to calculate the sum, how to condense back and forth. And I'm not sure why my system is taking so long. I have to switch probably to the other computer if it doesn't come up. Do you have the multimedia library brought up? Okay, so let me lay down the work or the groundwork for what we are going to look at. So, sequence of numbers. It's like a function. A sequence of numbers could be 1, 3, 5, 7, ... And this is an infinite sequence. I can have a finite sequence. Let's say another one. 2, 4, 6, 8, ... 20. This is a finite sequence. It doesn't go on forever. It only has the terms between 2 and 20. Now, obviously, I created these two sequences. I can create them arbitrarily, but I created them like this one has only odd numbers. So if I denote this first term by a sub 1, and I denote this term by a sub 2, and so on and so forth by a sub 3, you realize that I created a function. So when the index I equals 1, I get 1. When I equals 2, I get 3. When I equals 3, I get 5. So this will be a1 equals 1, the first term of the sequence. A sub 2 is 3, the second term of the sequence. A sub 3 is 5, and so on and so forth. And of course, I can also create the so-called general term. So on and so forth, a sub n, general term. So sequences can be given to us in two ways. Given the general term, a sub n, or given to us a relation or relationship. For example, a sub n equals 3 times a sub n minus 1 plus 4 for n greater than or equal to 2 or greater than or equal to something else. So this is a relationship. So as you notice here, we are given the general term. So if I plug in 1, I get A1. If I plug in 2 for n, I get A2, and so on and so forth. But here, and if you ask me, find A sub 10, no problem. I will replace n by 10 and give you the answer, whatever that answer is. We're going to look at examples in a minute. But here I cannot do that. If I want to determine 10, I have to determine 9. If I want to determine 9, I have to determine 8. Because A sub 8 equals 3 times A sub 7 plus 4. But if I don't have A sub 7, I cannot determine A sub 8. The point I'm making here is I have to determine everything before I determine the one I'm interested in. Here, that's not the case. I'm given directly the form of every element in the sequence. I plug in, I get the number. But here, I'm given a relationship. The relationship says that every term of the sequence depends on the term before it. So if I want 10, I have to determine 9. But now I don't have 9. So I have to determine 9, but I don't have 8. So basically, I have to start with A1 and A2 and so on and so forth. In this case, A1 has to be given to us. So on that device, my system is still not up. My multimedia library is not up. So I'm going to go to this computer. Okay, I'm opening that. Hopefully this one does not let me down, please. Is anyone in multimedia, is there a problem? I did get an email from Nikki this morning saying that the system is very slow today. Okay, I'm in. Does anyone have multimedia library brought up? Anyone?
I do.
Okay, so then it's my device, I guess. Thank you. Okay, almost there, I think. It says waiting for e-text. I think it's almost there, almost there. Okay, yeah. It doesn't allow me to log in. I have no idea. I'm gonna try on a different device now. Okay, this one allowed me to sign in. Okay. Sorry for the delay. Not sure why I'm having so much difficulty right this moment with this. Okay. Please open up. Please. I can make up problems for sure, but I would have preferred to direct you to the problems to choose also. Okay, I think it's almost there. Look at that. It opened. Okay. What was the page again? 752, correct? I think that's what I said. Yes, I said 752. Okay. 752. We just want to find terms given given the general term and given a relationship. It's called the recursive relationship. If my system ever opens up. Ah, a miracle has happened. Okay, so let's start with problems 1 through 12. If you want to choose, please do. And again, 752, page 752. Let me choose the first one and then you choose the next. So a sub n, so this is not a relationship. It's given to us, as you see, n plus 1, negative 1 raised to power n plus 1, and multiplied by n plus 4. Write the first 4 terms of each sequence, whose general term is given. So we're given the general term. It does not depend on a previous terms. So we're asked to find a sub 1. We're asked to find a sub 2, a sub 3, and a sub 4. That's all. All we need to do is just replace n by 1. 1 plus 1 is 2. Negative 1 to the second power is 1. 2 plus 4 is 6. Done. A sub 2, when n is 2. 2 plus 1 is 3, but negative 1 to the third power is negative. And 2 plus... sorry about that. 1 plus 4 is 5. So 2 plus 1 is 3. Negative 1 to the third power is negative, but 2 plus 4 is 6. So this is negative 6. A sub 3. 3 plus 1 is 4. Negative 1 to the fourth is positive, but 3 plus 4 is 7. And with 4, 4 plus 1 is 5. Negative 1 to the fifth power is negative, and 4 plus 4 is 8. And we can continue forever if we want to. We're only asked to determine the first 4 terms. Would you like to choose another before we look at recursive formulas? Anyone else? Anyone would like to choose?
Number 10.
Number 10 it is. Very good. In number 10, we have a sub n equals 2n divided by n plus 4. Same question. We're asked to find when n is